At the end of the day, ऊपर तेरे लकी है परफॉर्मेंस की तलवार, ऐसी दरिया है ये।
Assalamu alaikum. This is 1910-17 Yasir Zahid from Air University. This is DLD Lab 3, De Morgan's Law. In this lab, we are going to illustrate how De Morgan's Law can be implemented through circuits, and we are going to match this behavior implemented right here in the circuits with this truth table right here. We have two statements for De Morgan's Law. First one is x plus y naught is equal to x naught and y naught, and second one is x and y naught whole naught and is equal to x naught or y naught. We have developed these four schematics. This one is for x plus y naught, x plus y naught, x naught and y naught, x naught and y naught. Here we have x and y whole naught, x and y whole naught, then x naught, y naught, or x naught or y naught, x naught or y naught. Now we are going to match behavior of this circuit with the truth table. Right here we can see at 0 0 0 0 we have 1, at 0 0 we have 1. Similarly at 0 1 we have 0, at 0 1 we have 0 in both these circuits. These are right hand side and left hand sides of the equations, so they should behave same. Now for 0 1 and 0 1, for 0 1 and 0 1 we have 0, for 1 0 we have 0. Now for 1 1, for 1 1, for 1 1 we have 0. Hence this circuit matches the truth table of De Morgan's law function. Both the sides of equation, the right hand side and left hand side, are equal to each other. Now going towards the second statement of De Morgan's law. Now we are going to match this left hand side and right hand side of the equation with this truth table. Now for 0 0 we have 1, for 0 0 we have 1, for 0 1 0 1 we have 1, for 0 1 we have 1, for 1 0 1 0 we have 1 in both, for 1 0 we have 1 in both, for 1 1, for 1 1 we have 0 in both, for 1 1 we have 0 in both these circuits. Hence these truth tables match their respective circuit, and De Morgan's law is proved using these schematics. This is all for this video. Thank you. Allah Hafiz.
At the end of the day, ऊपर तेरे।
Assalamu alaikum. This is 1910-17 Yasir Zahid. This is the second part of lab 3. It was a separate function from De Morgan's law, so I created its schematic separately. Now what we are going to do is match its truth table with the behavior of this circuit, real-time behavior of this circuit. Let me start the simulation. At 0 0 0 we have 0, at 0 0 0 we have 0, at 0 0 1 we have 0, 0 0 1 we have 0, at 0 0 at 0 1 0 we have 0, 0 1 0 we have 0, at 0 1 1, at 0 1 1 we have 1, at 1 0 0 we have 1, at 1 0 0 we have 1, at 1 0 1, at 1 0 1 we have 1, and at 1 10 we have 1, then at 1 1 1 we have 1, at 1 10 we have 1, and at 111 we have 1. Hence the behavior of this schematic circuit matches with this truth table and its validity is proved. That's all for this video. Thank you. Allah Hafiz.
At the end of the day, ऊपर तेरे
Assalamu alaikum. This is 191017 Yasir Zahid. This is part of Lab 4's Proteus. Basically we are going to implement this Verilog, but first we have to implement its circuit in Proteus. So what I am going to do is simulate it and match its behavior with its respective truth table. So this is the truth table for this circuit, first circuit, which is not of AND B or not of C or D and D. Sorry. Now what we are going to do is change these bits inputs here and verify this output right here. So at 0 0 0 we have 0, at 0 0 1 we have 1, at 0 0 1 we have 1, at 0 0 1 0 we have 0, 0 0 1 0 we have 0 here, at 0 0 1 1 we have 0, at 0 0 1 1 we have 0, at 0 0 at 0 1 0 0 we have 1, at 0 1 0 0 we have 1, and for next three numbers we have 1. For next three numbers, which are 101 we have 1, 110 we have 1, 111 we still have 1, and then after that from 1000, at 1000 we have 0, and then after it at 1000 we have 0, 1000 1000 we have 0, and at then we have 1, and then 30, then we have 1, and after that we'll have 3 zeros here, 1 0, then we'll have 2 zeros, and this will be the third 0, and then after these 3 zeros we'll have 1, which will be the next number. This is our next number, 101 we have 1, and then for the last two numbers we have 0. For last two numbers, which are 10 and 111, we still have 0. Hence this whole circuit matches its respective truth table. Now coming to the second circuit, so just zoom in a bit. Okay, right here it's quite clear. Now at 0 0 0 0 we have 1. We are seeing these first 4 boxes and this last 1 box for the whole function. These are the intermediates. Okay, at 0 0 0 we have 1, and at then we have for next numbers 1 2 3 4. For next 4 numbers we have 1. For next 4 numbers we have 1. This is the first number, this is the second number, third number, and then this will be the fourth number. We have 1, and then we have zeros for next 3 numbers. Zeros for next 3 numbers. For 1 we have 0, for second we have 0, and for 3 we have zeros. 3 numbers crossed. And then for next number, which is 1000, we have 1, and then for next 3 numbers we have 0. For next 3 numbers we have 0. This is the first number, this is the second number, this is the third number, we still have 0. For next 1 number we have 1. For next 1 number we have 1. For next 1 number, this is the next 1 number, we have 1, and for all next numbers we have 0. Here we have 0, then at this we have 0, here we have 0. Hence at all 16 possible inputs, this circuit matches its respective truth table. Hence its validity is proved. That's all for this video. Thank you. Allah Hafiz.
At the end of the day, ऊपर तेरे लकी है परफॉर्मेंस की तलवार.